This is Physics Module 15 practice problems. So problem number 1, you can look at, there's a circuit drawn there, and I'm not going to draw it, but in looking at that circuit, you can see that it's 120 volts, and there is a resistor that is 501 ohms. And then we are asked, what is the current flowing through that? Well, we know that V is equal to I times R. So I is current, so we're just going to solve for current. So V divided by R equals I. So 120 volts divided by 501 ohms is equal to I, and the answer for that comes out with, you can have two significant figures. So it's going to be 0.24 volts over ohms, which is an amp. So 0.24 amps, abbreviated with the letter, capital letter A. Okay, so that is number 1. Number 2, again, in number 2, that says a circuit runs on a 9-volt battery. Okay, so we know that that is V. And it says if a physicist measures the current to be 0.50 amps, then what is the resistance? Okay, so again, B is equal to I times R. So we just need to solve for R. So V divided by I is going to be equal to R. So 9 volts divided by 0.50 amps is equal to R. And again, we can have two significant figures. And so this will come out to be equal to 18 ohms. A volt over an amp, so you'll get a volt over an amp, and that is equal to an ohm. So it's 18 ohms. Okay, number 3. A motor draws 315 watts of power. Okay, so that's power. If it runs on a 120 volt power source, so that's going to be equal to V, then what is the current? So find current, which is equal to I. Okay, so we know that power is equal to I times V. So we have power and we have V, so we can calculate I. So power divided by voltage is going to give you the current. Okay, so the power is 315 watts. Divided by the voltage, which was 120 volts. And and that will be equal to I if we do our math. And with two significant figures, of a watt divided by a volt is an amp, so it's going to be 2.6 amps, or 2.6 capital A. Okay, number 4. For number 4, we said that we're told that there's a 15 ohm resistor, and it draws 1.2 amps of current. So that's equal to I. This is equal to R. And the question is how much power? Okay, so we saw in the previous example that power is equal to I times V, but another way that we can calculate power is that power is equal to I squared R. So that's the one we will use for this problem. So it's going to be 1.2 amps times 1.2 amps, and then R is 15 ohms. Oops, it's 15. So then power with two significant figures will be equal to 22, and amp squared times ohms is a watt. So power is measured in watts. Number 5. For number 5, there is a circuit drawn. So I'll go ahead and draw it, and we'll talk our way through this. So this is a 215 ohm resistor, and the one in the middle is 151 ohms. And we are not given the power source. So we are asked to determine the effective resistance of the following circuit. So the first thing we do is we look at it, and in order to travel from the positive terminal around to the negative one, it has some choices to make. So it does not go through every resistor, and therefore we know that those resistors are in parallel. So they are parallel resistors. So that means that 1 over R effective is going to be equal to 1 over 151 ohms plus 1 over 215 ohms. So 1 over R effective is going to be equal to 0.00662. We need 3 significant figures. This is ohms, plus 0.00465. So 1 over R effective. If we add those two together, and this is taken out 5 places beyond the decimal place, so since we're adding and subtracting, we need to have that many there. So it would be 0.01127. So then to get R effective, it's going to be equal to 1 divided by 0.01127, and this is all in ohms. So the effective resistance for these parallel resistors with 4 significant figures will be 88.73 ohms. Number 5. Okay, number 6. Again, there is a picture, so let's go ahead and draw it so we can talk our way through it. We have a resistor here, and then we have another resistor here. Okay, so this says determine the effective resistance of the following circuit. So now in order to go from the positive terminal to the negative terminal, it must go through both of those resistors. So that tells us that they are arranged in series. And so we know for when they are in series that our effective is just the sum of them. We have 2 here. So this one is 215 and 151. So all we would do then to get the effective resistance is to add 215 ohms plus 151 ohms. So the effective resistance for these resistors in series is 366 ohms. Okay, number 7. Again, we have a drawing, so let's put that up here. Okay, this says determine the power drawn from the following circuit. So the formulas that we have for power are I times V or I squared R. Okay, so we are given, so this is 12.0 ohms. This one is 9.0. And this one is 20.0. And then we're told that the power source is 9.0 volts. So in either case, we need to know what I is. So we know that V is equal to I times R. Okay, so we need to solve for I. So V divided by R is going to be equal to I. So we know what V is, that's given here. So, and we can determine the resistance. So to go from the positive to the negative side of the battery, the current needs to run through every one of those resistors. That tells us that they are arranged in series. So all we need to do to get the resistance is get the sum. So our effective is going to be equal to 12.0 plus 9.0 plus 20.0, and the units are ohms. So our effective is equal to 41 ohms. So we have our, actually I guess we want to go out to the tenths place there. So I guess it would be 41.0 ohms because we added those. Okay, so that's the R effective. So then we can use that to get I. I'm going to go ahead and erase this. So V, I'm going to use this here, V divided by R equals I. So we were given the voltage as 9.0 volts. And the resistance is 41.0 volts. So we're going to have two significant figures. And 9 divided by 41 will give us 0.22. This is 41 ohms. So a volt divided by an ohm is an amp. So 22.22 amps is equal to I. Okay, now we can go ahead and use that then to calculate power, and I'll use this one. So P is equal to I, which is 0.22 amps, and our voltage was 9.0 volts. So P is equal to 1.98 watts. It's an amp volt, which is a watt. And we can have just two significant figures, so our power would be equal to 2.0 watts. Okay, number 8. Here is the circuit that we have. Okay, so this is a circuit. So again, we're going to start with the positive and follow that current around to the negative. And what you'll see is that, so it's going to start here. When it gets here, it's going to have, as it goes across here, it's going to have choices to make. It could go this way, it could go this way, or it could go this way. So that tells us that that all these resistors are in parallel. And the question we are asked is to determine the power. So again, power is equal to I times V or I squared R. But in either case, we need to solve for I. and V is equal to I times R. So we know this. If we can get this, then we can solve for I. So V divided by R is going to be equal to I. So our three resistors are 9.0, 19.0, and 15.0. They are arranged in parallel. So that tells us then that R effect 1 over R effective is equal to 1 over 9.0 plus 1 over 19.0 plus 1 over 15.0. And all this is in ohms. So the 1 over 9.0 is 0.11. The next one is 0.0526 because we need three significant figures. And the last one, again, with three significant figures will be 0.0667. So this will be equal to we can just go out to the tenths place, tenths, hundredths. So it will be 0.23 ohms. So then to get that's 1 over R effective. So R effective is equal to 1 divided by 0.23 ohms. So R effective is equal to 4.3 with two significant figures, ohms. Okay, so now we can plug that in here. We were given the voltage as 120 volts. So 120 volts divided by 4.3 ohms is going to be equal to I. And what you should get with two significant figures is 28. And a volt over an ohm is an amp. So that is equal to I. Okay, now with that, we are able then to calculate what we were ultimately asked for, which is the power. So power is equal to I times V. We just calculated the I as 28 amps. And the voltage was 120 volts. So 28 times 120, you're going to get 3,360. An amp times a volt is a watt. We can have only two significant figures, so we would need to go 3,400 watts, or you could say 3.4 times 10 square watts. Now, if you chose to calculate power using P is equal to I squared R, you're going to get the exact same answer. It would be, in that case, it would be 28 squared. So it would be 28 amps squared times R, which we calculated as 4.3 ohms. And amp squared ohms is equal to a watt. So 28 squared times 4.3. Again, you will get 3.4 times 10 squared watts. So it doesn't matter which way you calculate that, you're going to get the same answer. Okay, number 9. Okay, number 9 is one of the more complicated circuits, but we are told that an electrician has a 1, a 5, and a 10 amp fuses. And we want to know which one he should use to protect the circuit. So here's the circuit that we are given. Okay, so here's our circuit, here's the fuse, so we don't want to blow that fuse, and this is 120 volts, and this is 201 ohms, this one is 301 ohms, and this one is 211 ohms. Okay, so the first thing we have to do is determine whether these circuits, whether these resistors are in parallel or in series. So if we start at the positive and go around to the negative, we see that here it's going to encounter a choice. So these two are in parallel. But then it's going to join up together, and it doesn't matter if it goes this way or this way, it's going to have to go through that one. So this one is in series. Okay, so we'll just add that one to the resistance that we figure out on the other one. So let's go ahead and do the 201 and the 106. So 1 over R effective is going to equal to 1 over 201 plus 1 over 301. So that's going to be equal to we need 3 significant figures, 0.00498 plus 0.00332. And these are ohms, dealing with resistance. So that is 0.00830 when you add those together. And I have 5 places beyond the decimal here and here, so I need 5 there. So then R effective is going to be equal to 1 over 0.00830 ohms. So the resistance for these two here, up here, is going to be equal to 120. But we need 3 significant figures. We have 3 significant figures, so it's going to be 1.20 times 10 squared. Okay, and now what we will do then is add this series one to it. So plus the 211 ohms. And this only goes out to the ones place. So that's what our resistance will be in. So 120 plus 211 will give us 331 ohms. Okay, so that's our resistance, and we're asked which of these fuses should be used here. So the fuses are giving us the current. So with that resistance, we can calculate current because V is equal to I times R. V divided by R equals I. The voltage that we were given was 120 volts. The resistance that we calculate was 331 ohms. So a volt ohm is an amp, and what you should get with two significant figures is 0.36 amps. And therefore, the fuse that you should use, that should be used by the electrician, is the 1 amp fuse. Okay, number 10. Again, we have a circuit that is drawn.